Henk's going to be coming on in a second. Just before I do that, I'm just going to introduce him. Now, I've known Henk for quite a few years, haven't I? He's a global-wide senior Power BI business consultant, speaker, writer, and trainer. I like to think of him as a friend as well. And since 2013, Henk's received the Microsoft Most Valued Professional, that's the MVP award, in the categories of Excel and Data Platform. Oh, show off there. I get both of them. I've only managed Excel here for his outstanding expertise and community leadership. In 2018, together with, now I'm going to get this name wrong, I know, Michiel Rotsema, and Henk can correct that in a minute, also a data platform MVP, Henk founded Quanto Collective Analytics. Now, Quanto specialises in implementing Power BI solutions in medium and large organisations, and it also organises the Power BI Summer School, an international yearly 3-day event about Power BI and surrounding applications on a Dutch beach. Well, I hope that's in summer, because I know how cold it gets in the winter. They also provide different open in-company or online Power BI and data platform training courses. And Henk participates in congresses all over the world as a speaker or chairman, where I keep bumping into him. Henk's the author of several Excel and Power Pivot and Power BI books. He also wrote a chapter in Excel Insights, a Microsoft MVP guide to the best parts of Excel. And his latest book, co-authoring Michelle, is Extreme DAX. And being a consultant, mentor and trainer, he's extremely busy, but Henk has ample experience in helping organisations building bridges towards modern data-driven decisions. Henk, welcome aboard. Let me just bring you on, and I'll just feel free to unmute yourself, my friend. How is it in the Netherlands?
Yeah, well, first of all, thank you. I'm a bit blushing over here. You can see it quite well because of the light, but it was a great way of introducing. Thank you very much for that. And in the Netherlands, it's fine. We are not having that much of difficulties with the weather, as Australia had once this seasons. But yeah, we're doing fine. Thank you. And I'm glad to be here because it still is a very, very weak point, Excel. I've done it for years, and now I'm a bit more into the Power BI part, but it still has a lot of great things to work on. My main problem is that I'm not able to do two things together. So I would like to stay up on pace with Excel, but the things that change in Excel is so much faster that it's not that I'm not able to follow it anymore as I would like to do it with Power BI. And it's the same with Fabric. It was a great session, Paul. And again, getting on with Fabric and Power BI and Excel, it's way too much for one person. But it's so damn good going on this years, you know, finding so much new things in data. And I do love it. Really do love it.
Well, let's explain to everybody what's going on here. Henk's recorded a video here, which is about 32 minutes and 40 seconds long. So there you go, got the timing there. We're going to play that now, if Henk's all right with that. Feel free, like we've done before, start putting your questions in the Q&A. Henk is around. He can either be dealing with them and putting them in the chat, but I think actually, given the time, I think we'll just deal with them afterwards. I'm happy to ask them with you if that's okay. So Henk, thank you very much for your session on next level import with Power Query functions.
Good day and welcome to my session. My name is Henk VLOOTMAN. I am a senior Excel and Power BI consultant. During the last 11 years, I received the Microsoft Excel or Data Platform Most Valuable Professional MVP Award. I like to speak at conferences, and I'm also a writer of different Excel and Power BI books. I'm the founder and the owner of Quanto Collective Analytics, and we believe that collective analytics will give your company an edge in competitive businesses. I also play the role as chairman of the Dutch Power BI User Group Foundation. In this session, I'll show you how to import data while using an API string. The process starts with a secure connection to a website. This is mostly done by using an HTTPS secure URL. After the URL, there will be a statement containing a string with all kinds of information, such as username, password, required table, columns, etc. This string is called an application programming interface or API. If everything goes well, the string will return a table with requested records. Since every vendor builds its own type of UPA string, creating in Power Query the correct string can be a real challenge. On several occasions, I found that the API connection only allows to import a limited number of records during one API session. In these cases, multiple calls need to be performed to import all data. For each batch, the same API call is used, but with a small adjustment to the string to fetch the next set of records. At the end, all sections are added to one table. In some cases, you need to calculate the number of recurring API calls to receive the correct number of batches. I use the term page for each set of records. With each refresh of the Power Query statement, the number of pages need to be calculated, since new added data can add an extra page to the table. This session focuses on writing an M-language function. Bing's Copilot returns the following description of a Power Query function. Power Query function is a mapping from a set of input values to a single output value and is created from native M functions and operators. A Power Query function can be written by first naming the function parameters and then providing an expressions to compute the results of the function. The body of the functions follows the equals to and the greater than symbol. Optionally, type information can be included on parameters and the function will return a value. A Power Query function can be used to apply the same set of transformations to different queries or values and can be created and managed using the Power Query user interface. First note, there are two different flavors of functions, the built-in functions and the user-built functions. Second note, the single output can also be a table or a set of records. If you want to see all the built-in functions and more in Power Query, just open a blank query and use the M-language statement #shared. And I know developers that add this page as a hidden, non-refreshing table to have a direct reference at hand. One of the ways to import the different pages is using a for each M statement. First you need to find out how many pages you need to import, and based on that information you can create a table with at least one column that matches the number of pages, and that column needs to contain the variable of the API string. Unfortunately, each vendor has its own method to determine the number of pages. In some cases, you can start by sending an API call to receive that information. In other cases, there's another method. The documentation from a vendor can help you to find the right solution. Before we start the demo, I will show you several options on how to get information about the number of pages. First option. There are scripts returning the total number of records. In that case, you need to calculate the number of recursing pages by a simple calculation. The demo of this session uses this method. Second options. There are scripts returning the number of pages. Those are the nicest ones. Third options. There are also scripts that work on a return error base. Our query needs to keep asking for new pages until an error is thrown back from the service. This means you need to create an M-language statement that uses the try otherwise statement. All those different methods leads to a dynamic base table on which the API function will work. Today I present a very easy model. It does not require a login, since the source is a public website. It all starts with the principles how to create a basic table for each statement, and then use that table to import all movies regardless the year. The first part will be to create a base table with all the years. Step 1. The first year when movies are collected at the Box Office Mojo website. This is a static variable. Place this year in a parameter, since the first year is then easily changed. Step 2. The last year, basically this year, when movies are collected. This current year needs to be dynamic, since with every new year a page will be added. Step 3. The next step calculates the differences between the first year and the last year. This is the number of pages that needed to be imported. Step 4. The base table can be extracted into records for each year. The next part is to create a function in another blank query. Step 1. Analyze the API call. In this case, the year is the difference between the URLs to fill the different pages. Step 2. Write a function based on the differences in the URLs. In the last part, execute the function. Use the base table to retrieve the records of all years. Step 1. First apply the function to the base table. Step 2. Extract the records retrieved from the function into rows. Step 3. Check whether all data has been received. Now let's start the demo. The model starts with the creation of a parameter for the first year, named P first year. The value of this parameter will be 1977. Set the type to decimal number. Then add the parameter to a group named one.parameters. The next step is to add a new blank query into the model. Add the first year parameter in the first column. Now add a new column. In this column a calculation will be written. Calculations start with the datetime.localNow function, which returns the current day. Wrap around this function the date.year function, and the result will be the current year. Now from the current year value, extract the value of column 1, the first year parameter. The result is the number of years needed. This number is the total years to the current year, basically excluding the current year. Therefore, 1 year is added to this total. To get a list of years, add a new column and write the following built-in function. List.numbers, column 1, comma, custom. Expand the values from the columns into rows. To finish the table, remove the columns that are not needed anymore. Since these years are used in the URL statement, which is text string, take care that the data type of the column year is set to text. For now, we leave the table with the years as it is and concentrate on writing the function. To start the making of the function, copy the URL from boxofficemojo.com in memory. Be sure that the URL contains a year. The next step is to import the table by using the From Web connector. In the view of tables from the website, the second table contains the values we want to retrieve. Now do some cleaning stuff, like remove the columns we don't want. And set data types. And now the table contains all records for just 1 year. The next step is to place the URL in a parameter named pURL. This is not necessary, but it keeps the model manageable. Now change the source in the advanced editor. Within the code source, create a function. My preference is using a nested let statement, but it also works within one let statement. If that's your preferred method, just place the first line, the line with equal then and greater than signs, before the let statement on top of the script. Change the selected year into the parameter year. Keep in mind, the M language is case sensitive. After closing the script, rename it. Notice this script has become a function. A function will never load to the data model, recognizable by the italic font, and a function will always be included in the refresh. Now we return to the basic year table. Now we use from the Add Column tab the Invoke Custom function. Select the new made query and add the column year. The last part is expanding the content of the columns in rows. Finally, this is the table containing all the years. At the end of this session, I would like to show a professional use of a Power BI script. In this part, we look at retrieving a data table from a database source. Remember, we do not allow manual input. The queries need to get their data automatically. This base intention is necessary for setting up a scheduled refresh in the Power BI services. These are the challenges we need to address. The source accepts a limit of 100 rows per run, which is added in a parameter called PNB limit. We focus on a table with the financial information. The name of the table is fin outline. This name is the same as used in the database. Other parameters contains the base URL, the needed credentials and the base API settings. We know that the table contains 351 rows. To get all the data from this table, we need to run 4 pages, with each run containing a batch of 100 rows. Let us look at 2 functions. One is a function to create the necessary list called FNC list, and a function to extract the desired columns, the function FNC field list column names. The other functions are either used to get the necessary tokens or a function to convert Java stored data as a Union calendar date. How does the FNC list function work? First, the accepted parameter is called upper. This is the upper amount of page runs that need to be performed. This parameter is used in the list.number functions, which will return a table starting from 1 to the upper number. We can test this function by filling in the upper parameter with a number. In this case we use the number 4. The function fieldListColumnNames is used to create a list of column names. The parameter accepts the name of a table. This actual table has one column that contains the names of the column headers. This is a useful way to keep control over the columns we want to import. By the way, the name of the table and therefore the name of the parameter is called field list fin outline. In the first part of the demo, we take a closer look at the applied steps. Then we look at the code in the advanced editor. As you might notice, we renamed 3 steps. These are the steps with the names number pages, create page list, and run query for each page. Do note the absence of the spaces. Not using spaces in applied steps names lead to better reading of the code in the advanced editor. In the window Applied Steps, the first 5 steps are used to create local variables, shown by the icons after the name. The variables are all part of building the API string. The step named JSON query uses a function called mdQuery. This function builds the string that forms the base of the API. The step named URL only shows the value of the public parameter with the base URL. This step is not necessary, since the result of a parameter can be called directly from within the code. Placing the public parameter into a local parameter is only done to create a better overview of the API string components. The step named table name contains the local variable of the table name. The value needs to match the exact table name as used in the database. The step column names returns a list of the headers names by invoking the function fieldListColumnNames. In this case it uses the table fieldListFinOutline. The last step uses the function token that retrieves a token from the host database service. This is a security feature, so I'm not showing the code of this function. The next step after the declarations of the local variables is called source, and it represents the start of the script. It builds the API string and therefore contains all the elements of the previous named local parameters and some global parameters. The result of this step is a table with a record named data. This is the record we're interested in. Note the record of the data is shown at row 10. In the step number pages, the value of row 10 is expanded into a list. The next 5 steps transform the list into a table, which contains the value of the last page and the total records. In the step create page list, the function list is called, with the value of the column last page used as parameter. Then the return table is expanded in the column named page. A new column is made based on the API call. Note that the page parameter is set to the value of the page column, which in this case contains the records of 4 individual JSON tables. The next 4 steps are all needed to expand the 4 JSON tables into one table. Since all tables have the same structure,
Expanding the column instead of each individual JSON table will create a complete table. Expanding the column makes this step independent of the number of pages. In this step, expanded WS fin outline 1, the values of the local variable column names, as created in step 4, will be used to expand the needed columns. All the hard work leads to a super efficient way of working. If you want to import another table, you just copy the group fin outline, rename the new group, and adjust the local parameters in the script. Change the content of the renamed field list table to the header names of the new table, and you are good to go. If you want to add or remove columns, just change the field list table and refresh. To finish this session, let me show you the M language script in the advanced editor. I will highlight some of the important code sections. As you can see, the first lines of the codes are used for local variables. Due to the unstructured way the Power Query script works, it really does not matter where you place the variables in the code. Best practice is placing all the local variables at the top, since they're easy to find and they give structure to your script. As you can see, we like comments. They are placed in the green font. Use 2 backslashes before text to create a comment. The next part of the script, beginning with source, creates the first section of the API string. I like to focus on 2 sections in this code. First, the use of the M code relative path. If you are working in Power BI desktop, manual refresh will work well without the statement. In the Power BI service, an API built without the code relative path will fail. In the service you want to set a scheduled unattended refresh. Since you are connecting to an anonymous source, the credentials are stored in the API string, Power BI service will throw up an error. Using the code relative path implies the use of one base URL. Secondly, note that the page variable has the value of 0. In this scenario, the value 0 will return an information table, which data we need in the second part of the script. Now take a look at the second part of the code that built the API string. This step is named Run Query for each page. The code is nearly the same as the code in the step source, but I like to emphasize 2 different pieces in this code, compared to the source code. First, I like to zoom in how the first information table and the second table with all the records is made. If you look at the code in the source, it just retrieves one table with information. You can see this by the code source is JSON.document. In the step Run Query for each page, the API string is executed in a new column of the base table, recognized by the table.addColumn statement. The each statement will take care that every row in the table will incorporate the JSON file with the appropriate data in it. Notice the page statement in the step Run Query for each page that builds the API string. In this step, the page is referring to the column page in the base table. In this situation, it is a column with 4 rows containing the number of 1 to 4. The JSON table in the row will contain the right set of data due to that page number. The calculation of the page number in the host database uses the value in the parameter p and b limit. This parameter, set to the value of 100, is passed to the host database in the API string. The use of parameters takes care of the structured passing of the code in the API string for at least twice the same code, the information table and one data table. In our case, the code is passed to the host 5 times, 1 for the information table and 4 times to retrieve the different data tables. What we achieved with this code is that the import of the table depends on the variable content of the host database without any manual interaction. If the number of rows exceeds the new multiple of 100 rows, the host database automatically adds 1 to the page number. Since all steps works automatically, based on parameters and information out of the previous steps, this code is what we call bastard proof.
Henk, thank you very much. Welcome back again. Different background now, I see, from the one before. We have had some Q&A in the meantime.
Yeah.
So just before I go into that, because we've got loads of time for questions here, I'm going to start off with one as an Excel MVP. Henk, why did you defect? Why did you become a data platform? You know what's so?
It's not a deliberate choice. It all started in 2010 when something in Excel came in with this power pivot in Excel. And that solved a lot of questions and problems I had in Excel, mainly because of the huge amount of data I can put into power pivot. And it's basically the ecenter of Power BI. So I started over there, and then I met Michiel Roosma, and Michiel was at that time working in at Microsoft in the Netherlands, and he needed a face to let's say show Power Pivot to the Dutch audience. So I went to the Microsoft website and did some things on that, and we stayed together with that. And after a while, we decided to write a book on Power Pivot. So we have written 2 books about Power Pivot. And then Power BI came around. And it was a logical switch because, you know, Michiel didn't do anything in Excel. And I was fascinating about things what happens in Power BI. So that's why I take that switch. It wasn't not deliberately, but I cannot do everything. That was the main problem.
No, fair enough. But we missed you. We missed you. Now we've had some questions. The first question I've got, and apologies if I get the pronunciation wrong, I think is from Tao. It said, I used to connect to a website via API to extract a table with around 10,000 rows. Although I applied multiple calls at the same time, Power Query ran extremely slowly, only around 50 rows per 2 to 3 seconds. Do you have any tips of how to make it faster? And do you think, was it restricted by the source?
Yes, first of all, of course, your internet speed will be influence this the speed, but I do have the same problems with sometimes I use an API and it's extremely slow. Most of the time it's a setting that is on the host database delivery, and it's the way the how much bandwidth they give you to get your data through. Most of the time it's not wise to try to get tables in at the same time, but I know Power Query will try to do that. So that will slow down your input of tables. I'm actually having a real problem with an API situation like you, and then importing Excel tables from a SharePoint is the bottleneck. that makes it's very slow. So it's also depending on a couple of situations. But first of all, try to find out if there is at source data host, if there is a bandwidth that can be set wider for you.
Now, we've only got one more question. I've got 5 answers. A name I can pronounce, T, has asked the question. Thanks, Henk. I have a question. If we need an API key to connect to a website, how can we ensure the security while the code needs to be hard-coded into M codes?
A very good question. Let's say 2 things. The script I show is used in Power BI and also used in Excel. Now, first of all, if you connect to a database source on the website, be sure that it is an HTTPS settings, an HTTPS setting, so that you know you have a secured connection to the database. Secondly, well, what you basically do is create in the API string the information to retrieve a table. And that means that you have to add to that string all the information he needs to get that table. That means it is hard-coded in the M language. Now, if I'm working in Excel, I cannot guarantee that nobody opens the Power Query Editor and then looks at the codes. If I'm working in Power BI, the normal user cannot see my code and cannot see my data behind it, and they only see the dashboards. So in that way, it's more secure in Power BI than in Excel. But it's still a problem because you need to have your credentials hard-coded in that way. But yeah, well, that's how it works. I don't know another way of getting my codes into the API string than by hard coding it in Power BI in the Power Query Editor.
That's a fair problem. Well, look, while we are waiting for more questions here, let me ask you one to get you on with, which we scripted earlier. He lied. What would be your top 3 tips for APIs and Power Query?
The top 3 tips, yeah, well, basically the main problem is that first find out how it will work, because there is a different approach due to different database host services. But most of all, what I really like is using parameters, because using a parameter means that you can use it everywhere in your code and it will always be the same. So you can code, if you like, your let's say your credentials in the script itself, but placing it outside of your script and parameter, that's the first thing I would like to do. Secondly, and that's obviously, but not always obviously, try to get your code that it will run automatically. So a refresh does mean that you don't need to go into your code and change some settings and then do your refresh. No, the refresh means refresh and the settings will set up things. So I use, for instance, that list.numbers function to create a dynamic list based on the number of records I have. So I don't have to do that manually. So that's number 2. And the third part I like to do with that is try to get the things sorted out in a way that it's too easy to maintain, because it's a complicated thing, an API string. And what you need to do with that is to make your code as, let's say, as less as possible. So in this case, I needed 2 times the API string, one for page 0 to get my information table, and the other part was using my page number refresh. Those codes are the same. And I would recommend that you try to make those things yourself as let's say readable as possible and as less changes as necessary. That would be my 3 main advices if you make an IPA.
Thank you very much. Let me introduce you while we're waiting for any other questions. I'm just going to put it on screen. He's trying to make himself look presentable as we go. Here's Miles, who is a partner in crime here. He's actually in the background in case I drop off. He's there to help out in the meantime and keep me honest. He's actually got a question for you, Henk. So, Miles, what's your question?
Yeah, hello everyone. I'm Miles. I'm in the background. Yeah, Henk, my question is, if you have, let's say you've got a URL, you're trying to take a table from a website, and there's minor changes between sites. Like, let's say you've got one page that's got the data for 2022, and then another page that's data for 2023, and another for 2024, and it's just like a small one-digit change in the URL. Is there a way to automate it so that it goes through the different years, like scraping the same table from all the different ones, or do you have to do those all individually?
No, it's in the demo I showed you a way to do it. The first thing you need to do is to find out that URL thing. What is it? And you need to find out what the change is. So, for instance, for now it's let's say 1, 2, 3, 4 because I need to have 4 stages in it. But if you look at the years, it was the years. So I created a table with the years. So the things you need to do is to create a table which has the differences in the URL in it. So if it's a number, let's say if you got page 200, 400, 600, 800, something like that, you know, because that's also a way of retrieving data, then you need to have a table that contains the difference, so the 200, 400, 600. So we'll make a table of 1 to 4 and then multiply the result with 200 or something like it. And then you can use that one in the URL to create the difference. I don't think it's a good way of changing things by copying the same structure every time and then manually change it, because if there's something else coming in, then you need to go into the code and need to do it again. So try to find out ways of getting that automatically done. And the only way I know how it works is using a table with, let's say, the correct order, or appending it. If I had, I showed you a little screenshot of a try otherwise situation where I need to get in pages until I have everything, and that's a simple append. But append in one Power Query statement. So I'll loop through all the numbers I have, and then add one until I got an error and it says then quit. Then you have everything. But basically, try to find a way that you do not do anything manual, and if something has changed, that it will be added automatically.
Okay, cool. And just one more question. Have you, having tried this before, have you run into many websites that have tables that you haven't been able to pull using the API? Like, is it a common is it commonly able to be brought into Power Query like that, or have you run into issues often?
Of course, there are lots of issues. First of all, you need to have knowledge about how the API is built on. And secondly, then you need to find ways to get everything you want. But most of the time, I first start with going to the vendor of the database and then try to find the information they have on their API. So there are websites with specific database vendors, which tells you which tables are available and which fields in the table are available and how to set up a string to get that. And most of the time they don't tell you how to do it in Power Query, because there are also other ways to get it in. You can use an R script or something like it. But basically you need to find that API and rebuild it to your own convenience. So it's there's no standard way. It's all depending on how the database source vendor wants you to set up your API, and that's the first step to find the solution in Power Query.
Okay, thank you.
Thanks there, Miles. Just going back to the first one, I put something in the link actually, which is slightly different to that one, which is something where we had a similar problem a while ago, and it may answer a question in there of Miles' first one. We've had another question though, Henk, from Tal, who's been quite vociferous so far. Thank you, Tal. He said, "Hi Henk, is there any issue if we schedule a refresh for a dataset based on API? I used to have lots of problems with PostgreSQL and ODBC connectors on Power BI service."
Yeah, there are things in difference in the services, and I really don't know if I emphasized it in this demo. But if you use an API and use it in Power BI Desktop and create something like the API, it will run. And there are times when you're going to the services that the service doesn't allow it. And it doesn't allow it because you use an anonymous entry. So your credentials are anonymous because you have your credentials in your API string. And that part of the way is that you need to use an end statement relative path. And if you use the base URL in a parameter and you use the relative path to create your API string, and then it will refresh in the service. If you don't do it, most of the time it will not refresh because of the limitations of the service that says if you go to an anonymous source, be care that your credentials are not visible for it, and they will not refresh it. And it's you can say something about it because you import from somewhere that the service doesn't know and doesn't recognize. So they created a way that you need to address it by using code relative path to get a base URL, and that's a trusted URL most of the time. Is that a bit of an answer?
Yeah, that's a bit of an answer.
It's right. It's quite difficult to find these things out because it's not stated that directly in your line, and doing it in Power BI Desktop and it will run. And then you think, oh, it will run the service as well. But no, you need to take care of that kind of things. Building an API string is most of the time doing it and try and error.
Henk, it's been brilliant talking to you as always. I miss that we've caught up face to face many times. It's been a shame post COVID that we haven't done it for a while, but we will catch up again soon. I'm going to miss you. So. I'm going to miss your music.
Thank you very much.
Boogieing along in the background, and everybody was taking the mickey out of me while that was going on there. So thank you very much, Henk. If anyone has any more questions, Henk may be graciously around for a few more minutes. He's happy to deal with the questions in the Q&A and just type up chats. Feel free. But otherwise, Henk VLOOTMAN, pleasure as always to see you. I miss you, my friend, and I hope you have a great rest of the day. And thank you very much for being our second presenter on Excel Virtually Global.
Thank you, Liam, and I hope to see you soon in live, live and well situations. Thank you very much.
Me too. It's about time I got that. Brilliant. Thank you very much, Henk. Cheers.
Okay. Thank you. Bye.
Bye-bye.